I didn't want to do 2 words. Yeah. Yeah. Okay, everyone, let's get going in the name of staying on time. Looks like it's a popular session. That's great to see. Urban trees are important. I had no say in the matter. Yeah, unfortunately. Okay, so my name is Scott Krayhoff. I'll be one of the chairs, and my co-chair is Paul.
Yeah, Paul.
Okay.
From University of London.
Okay, so Paul and I will be chairing the session. The title of the session is Local Climate Impacts of Urban Street Trees, Advances in Modeling and Measurement, just in case you're in the wrong session. And so, yeah, street trees, I'm really excited by this session. I think we have some really great talks today. Street trees, as you probably all know, because of their vertical extent, they have unique impacts on radiation and flow. And then also they're living beings, right? So they're responding to their environment, altering the environment. So I think we're gonna have some sessions, some talks today that are gonna enlighten us on some of their special properties. So before we get going, if you're presenting today, Paul here is going to be sitting right here up at the front. He's going to give you've probably seen in the other sessions, 5 minute, 1 minute, and stop now warning. So please pay attention and please, so we can stay on time. Anything else you want to add? No. Any questions? Okay, well, let's welcome up our first speaker, Dr. Luciano Massetti, speaking about how the canopy density of different tree species can affect ground surface temperature.
Thank you. Thank you for coming. I'm going to present this work on behalf of the group, of this group that is composed by Martina Petralli. So I'm going to present this work on behalf of Martina Petralli and Professor Simone Orlandini of the University of Florence and David Permute from the Ben-Gurion University of Negev. With this group, we are working. In this group, we are working it's quite for almost 20 years. We are working in monitoring the urban microclimate and studying the relationship with urban morphology. For example, this preview of a map is the thermal map of Florence that we produced in a previous study, and now is going to be included in the urban green new plan for urban greening of the municipality of Florence. So we were proud very much of this result because it's like a kind of application of our work. And of course, we are focused among the urban morphology on trees, and on of course of the implication about the implication of say microclimate on thermal comfort. And in this study, we focus on the shade of the trees. Right? We well know that tree shade is very important for the mitigation of microclimate and is an important regulatory ecosystem services provided by trees. And of course, tree shading is not something that is fixed. It depends on tree species and depends also on phenology of the trees. So the objective of this study is investigating how tree species and the changing during the growing season of these tree species might affect the surface temperature in cities. We choose a garden in the area that is just next to the historical city center of Florence in Italy. And this is a garden that there are present several tree species that are common in the urban greening of Florence and the other Italian cities. So it's quite well, in a small space, we can find several species. So therefore, we selected three species, and three individuals for each species, more or less with the same dimensions. And one is evergreen, Quercus ilex, and four deciduous, as also chestnut lime tree, plane tree, and European nettle tree that have different timing phenology, leaf phenology timing. So canopy vary differently across the season. Then we used for measure the impact on surface temperature of asphalt, concrete tile with a layer of asphalt on top and put inside the layer of asphalt surface temperature sensors. We put these under these trees, and we use one as a reference exposed to the sun, and another one exposed to an artificial shade of a mesh. We measure also plant area index, PAI, during the season using a Lycor LA 2000. And we usually put PAI is actually the combination leaf, the shading of the leaves and also the wooden part, so trunk and branches. And this is an example of the tile, the tile with asphalt on top. We do this measurement in the middle of the day, the hottest hour of the days, and during days of sky low wind days. Here, just to show an example with fisheye lens pictures of the volume of the canopy of this species. So we can see, for example, that during the early spring, the canopy of this deciduous species is quite different. So some of them leaf out earlier than others. The same if we look at autumn. So here we can see that some species lose the leaves or leaves become dried earlier than others. So these are the measurements that we take along the season of PAI. And here you can see difference. For example, we divided in three parts the season. The first part is when the canopy develops. The second part is in late spring and summer, when the canopy is more or less stable. And the last part is when the plants lose leaves. Here we can see that, for example, Esclusipogastanums and Tilia peroropea develops the canopy earlier than the other species. Of course, the green species has more or less a constant PAI. And this is the PAI index, and this on the x-axis is the day of the year. So we express the time according to the day of the year. That means 1st of January is the first one, day one, and 31 December, day 365. So we selected one measurement, one day of one sunny day in each of these three periods, and we analyze in the result, let's say, the surface temperature. And actually, we analyze the reduction of surface temperature compared to the surface temperature on the asphalt exposed to the sun. In this day, that it was the 19th of April, we see that the temperature of the sunny asphalt is around 50, 52, and the reduction vary between 13 degrees, minus 13 degrees, to 26 degrees for the evergreen species. And here, for example, we can see that with the fisheye that Celtis australis that lose leaves bulbs open earlier is a lower PAI, and this corresponds to lower temperature reduction. If we go in the middle of the season, you can see that now the difference are more or less, the reduction is similar to all the species because they are in full canopy and they have a similar PAI apart from Celtis australis that has a lower pi. And so temperature of sunny asphalt is very high, 70 degrees. And the air temperature in this day was 34 degrees. That is typical of a sunny day in summer. In these days, we have several consecutive days with temperature higher than 35 degrees. And here again, we see there is a correspondence with PAI. Going to the end of the season, so during autumn, we can see that PAI are very different from each other now because they have different timing. And again, if we look at, for example, Platanus acetifolia that loses the leaves and even maintain yet dry the leaves even until December in Florence at least. Again, we can see that there is a correspondence between the PAI and the temperature reduction. Finally, I will present just the temperature, surface temperature, the absolute value surface temperature in those days, the days that we studied, and we can see that again in the central. I presented before this to see that the reduction of temperature is very high, and then going to the other 2 days, I want to point out that, for example, even though her temperature was similar both in April and in September, October, surface temperature at sunny asphalt is different. And this is due probably due to global radiation, that is the main source of heat of the surface. While if we look at air temperature versus surface temperature, we can see, for example, here that surface temperature under shaded surface is very similar to air temperature. So the main driver for surface temperature in sunny, on sunny surfaces is radiation, and while with shade is air temperature. And these are the conclusions. So we found out in our study that temperature reduction can reach more than 30 degrees when the species are in full canopy. That this reduction depends on PAI and vary across, especially at the beginning and the end of the season, is different from species to species according to the phenology, and that of course the most most important effect of shading is that it blocks direct solar radiation, short wave radiation, and eating less the surfaces, also the long wave radiation emitted by the surface. And that's all. I put a picture of the garden taken 50 years before. This small slide here is the same garden 50 years before.
Thank you.
And thank you.
We have time for 1 or 2 questions. So right here.
You used a 30 centimeter by 30